Passwords are often stored as hashes. That's the way it should be done. Hashes are one-way functions, which means that we can't take a hash and reverse the function to create the original input. So how do hackers take a database of hashes and get all the passwords in that database? Well, they crack those hashes, and we'll take a look at cracking hashes in this exercise and see how the hackers actually do it. There's a couple different ways that we can do it, a couple of different tools and approaches that we can take. Two programs that are commonly used to crack hashes are John and Hashcat. Hashcat is newer and more powerful, especially if you have a GPU on your system, a powerful GPU. I got a phone call from my brother-in-law. He was working as a detective. They were trying to get on somebody's computer in order to investigate whether that person had illicit material on his computer. And he called me up and he's like, hey, I've got this workstation. I've got like five NVIDIA GPUs on this computer, and I've got Hashcat, super powerful rig. He's like, can you walk me through how to use Hashcat? And I was like, sure, let's do it. So we were able to crack a fairly sophisticated hash really quickly using his hardware, using Hashcat. We'll take a look at dictionary attacks and brute force attacks. First, let's get set up. So we're in our Linux system, and make sure we're in our home directory, and we're just going to delete everything in there. rm-rf sci-fun files. Not everything. I shouldn't say we're going to delete everything. We're going to delete the sci-fun files directory if you have it. Go ahead and run that command. You can run it multiple times. It's not going to hurt anything. It's going to delete everything, whether it's there or not. So I ran it twice. Didn't give me an error message that it couldn't find it. So that's all fine. I'm just going to copy and paste that command, that git clone command. Because in there, I've got some stuff we can crack. So let's cd sci-fun files now. That folder was just created. And there's a folder called crypto crack hashes. So I'll look at my current working directory. I'm in home Ubuntu sci-fun files in the folder crypto_crack_hashes. And so if I ls and take a look at the files, there's two files in there. There's some LinkedIn hashes. So LinkedIn was breached a few years ago. I was part of that data breach as a victim, not as a perpetrator. But my password hash was leaked. I've also got a text file with some bcrypt hashes there. So we'll see what it looks like to try to crack LinkedIn hashes versus cracking bcrypt hashes. So LinkedIn, all those hashes were hashed using SHA-1. SHA-1 is not super secure. And LinkedIn at the time, they were not salting any of their passwords either. So kind of a double bad on LinkedIn's part. Just the way it goes. So I'm going to cat LinkedIn hashes.txt. These were some of the most popular hashes found in that breach. Some of the most common passwords that people select. So we've got all these hashes here, but we don't know what passwords were used to generate those hashes. So it's our job to try to figure that out. Notice, again, they're all the same length. It could be a 3-character password, could be a 20-character password. All those passwords are going to generate the same length of hash if you're using the same algorithm. So let's sudo apt update our system. Make sure to get all those letters there in update. That's a hint for me. Looks like I've got some stuff I could upgrade. I'm not going to upgrade it right now. I'm just going to move forward, and I'm going to sudo apt install John space hashcat, and I'm going to put the -y. That's just going to automatically confirm, yeah, I actually do want it. So skip the prompt asking me if I actually want to move forward and install that stuff. So So my virtual machine, this Linux virtual machine, does not have a GPU. It is possible to create Amazon EC2 instances with powerful GPUs. They're also going to be expensive per hour, relatively. And the Learner Lab also prohibits us from starting some of the most expensive stuff, so we'll be fine. We're just going to be using the CPU to crack everything right now. I'm just going to run John just to see, like, do I have it? Yep, John is there. Do I have hashcat? Yes, I do have hashcat because it shows me the help. So all of that's good. I'm just going to type clear to clear my screen, take me to the top, and we're ready to go. A dictionary attack tries a list of words of commonly used passwords. So we can take a look at John's default dictionary, and we'll just run tail. That'll look at the bottom 10 rows. Tail in user share John password.lst. So these are the last 10 entries only. So for example, somebody might use the password go or dirk or quirt with a capital Q. A dictionary attack will just hash each of these words in the dictionary and compare those to the hashes in our file. So if our dictionary has 10,000 words, we're actually going to hash those 10,000 words and compare them to what we have in our LinkedIn hashes file, for example. So there's a weakness there. Let's run hashcat, because hashcat's the best. And you know what I'm gonna do? I'm gonna copy and paste this because there's a lot of characters there. What's the chances of me typing that without creating a typo? Low. Whoops, I just hit the up arrow key accidentally. I'm gonna paste it again. And let's take a look at what this command is doing. So we're gonna run the hashcat program, and A is the attack type. 0 is the attack type for a dictionary attack. M is the hash type. 100 is the SHA-1 hash. So I know that LinkedIn was using SHA-1, and there's ways that you can often figure out what hash something was using just looking at the hash length, or sometimes they just tell you. Then I give it the name of the file that contains all of my hashes. And then next is the location of the dictionary I want to use. So we installed John really just to get that dictionary here, but we're using hashcat to actually do the cracking here. So I'm going to hit enter, and hashcat is going to do its job. Takes a second to warm up sometimes. So initializing backend runtime for device number 1. Please be patient. Okay, I'll be patient. This will go pretty quick. It's not actually computing the hashes right now. It's really kind of just getting warmed up. Hashcat is like, it's like the container ship. Like, it's a big beast, and it takes a little bit to get moving, but once it gets moving, it's got all that momentum, and it can really do a whole lot of work. So once it gets going, it'll go quick. Just trust me on this one. I know it's like really quick. We just had to wait like a full minute. Okay, it just finished. Looking at this status output here, it says recovered 6 out of 7. So we had 7 hashes in our LinkedIn file. It found 6 of them. Why didn't it find everything? Well, one of the passwords in that LinkedIn file just wasn't in the dictionary. That's a weakness of dictionary attacks. If your dictionary isn't big enough, you might not find every single password. If I scroll up, I can see here that we had this first hash was associated with the password 123456. Yeah, that's a very common password. Lots of people, the second hash, used the word password. These are such terrible passwords, but these were the most common ones in the data breach. Lots of people use 1234567889, QWERTY, Sunshine, and 654321. All right, so the dictionary attack was effective. We were able to crack these hashes, but we didn't find everything. So what would we do next? Well, we could get a bigger dictionary. There's a few thousand words in John's dictionary. It finds a lot of common passwords, but it's not really exhaustive. You can find password dictionaries that have millions of passwords. So one step is to get a better dictionary. Let's say if we cleared our screen or we lost that output for some reason, we could always show with the -- show option with Hashcat what was actually cracked, and it'll spit it out there for us. So if we ever lost it, like we don't want to re-crack everything because this is a very computationally expensive operation, but Hashcat saves it for us, so that's fine. But what if we didn't? We want to crack all 7 out of 7, so we want to do a brute force attack. A brute force attack will find every single combination of characters given some specification. So let's take a look at this brute force attack. I'm going to copy that command and I'll paste it in and we'll watch it run. Paste as plain text. All right, so what this is doing, the attack type is different. So instead of A0 for a dictionary attack, we're doing A3 for a brute force attack. We're still using the same attack hash, the SHA-1 hash. We're still looking in that LinkedIn hashes. We're looking for that one left. And here we've got the format. So the question mark L in this case stands for lowercase letters. And this is how many letters we're looking for. So if we know someone's password is 6 characters long, we would do question mark L 6 times. All right, and it finished. We found it with the brute force attack. What was that last hash? The next most popular password was LinkedIn. Not a great password. So let's look at how fast we were going. 54,924 kilo hashes per second. So we were looking at, 54 million hashes per second. So we can try 54 million different passwords every single second. That's fast. But as the number of characters of our passwords grows, the number of possible passwords also grows tremendously. So that's good. As it's going, you can hit the S key to show the status while it's going. You can see how far along it is and how long it's going to take before it finishes. But Hashcat did a good job for us there. Let's take a look. I'm going to cat the bcrypt hashes file. We've only got 2 of them. Notice we've got the hash type, we've got the adjustable work factor, and then there's the hash that includes the salt. Okay. We are going to run this command now. I'm going to copy it and paste it. We'll take a look at what it's doing. Paste as plain text. All right. Bcrypt. How long is this going to take us? So here we're looking at the attack type. It's a brute force attack. 3200, that is the bcrypt hash type. We're doing an incremental attack here. So notice I've got this mask here. We want to check up to, how many characters is this? 1, 2, 3, 4, 5, up to 6 characters. By doing it incrementally, it'll start with 1 character, find all the 1 character passwords, then all the 2 character passwords, then all the 3 character passwords, etc. Look at how absolutely atrocious this speed is. When we were doing SHA-1, it was 56,000 and change for our speed. Here we've got 12. Like, just absolutely stupidly slow in comparison. It looks like we're speeding up. We're up to 29 hashes per second. Yikes. That, I mean, it's terrible. We can see the passwords that it's trying to hash right now, 6C through 6F. I'm going to hit S to show the status. Put my cursor in there. Hit S to show the status. We're up to 3 character passwords now. Like, oh my gosh. This is not great. How long is this going to take us to do a brute force attack? Estimated, where's my estimated time left? Time estimated 4 minutes and 9 seconds left. I'm going to pause the video right now. All right, I'm just going to show real quick. Now I've got up to 4 character passwords. 1, 2, 3, 4. So it's doing lowercase and letters. So we can see the candidates that it's checking right now. And the time estimated, and this is just to check the 4 character passwords. It's 1 hour and 16 minutes to do this brute force attack. So this is going to take a while. If you want to let this run, more power to you. I don't want to sit here for potentially hours and hours. Just realize that every time we add an extra character, that time is going to increase dramatically. So I'm going to nope out of this. I'm going to press Q to quit. And Hashcat's just going to shut down. We're going to try an easier one. Question mark D is going to show us passwords that just contain digits. So many fewer characters, instead of like lowercase, uppercase, and numbers that gives us a character set of 62. We're just going to be checking digits. And we're going to be really focusing on 1, 2, 3, 4 digits here. So I'm going to right click, paste that command here. So it's a brute force attack, but only looking at 4 character passwords composed only of numerical digits. And this should go faster just because it's easier, because we want some success. I'm going to hit S for status, and we can take a look at the candidates. It's checking 7, 2, 3, 4 through 7, 9, 1, 2. And gosh, even though this seems simple, it's still going to take 11 minutes and 45 seconds. Yeah. This is one reason why if there's a data breach and a password, we got the password database, we have all these hashes. If the hackers see like, oh, these were encrypted, if these were hashed using bcrypt, it's kind of like, we're not even going to try a brute force attack because it's just going to be stupid. You would try a dictionary attack, or maybe if there's a very high value target, like if you hacked a bank, and you've got a very rich person's password hash there, maybe their hackers are going to focus on that one specific hash and try to crack it. But this is just so slow. It's just kind of insane. So I'll let this run for a little bit. I'll pause the video again. I'm willing to wait 10 minutes for this to complete. And right after I said that, it spit out the answer there. Okay, so I've got a hash. It spit out this one hash. It found that that hash is 1999. Okay, so if somebody used the password 1999, it would have been cracked using hashcat here. The other password in here is not a 4-character password composed of numbers, so there's no reason for me to let this keep going. I'm just going to Q to quit and shut it down because I recovered what I wanted to recover from that example. So what are the takeaways? Well, if you're storing passwords, you want to use a secure algorithm. Try to make your passwords crack resistant. To protect yourself, choose unique passwords on every site because you don't know how the website is storing your password. They could be storing it in clear text. They could be using SHA-1 with no salting. They might be using SHA-2 with salt, or they might be using something like bcrypt, but you don't know. Eventually, some website where you have an account, it will be hacked. And if they're using a bad algorithm on website A that gets cracked and you use that same password on a website that is even storing your password securely, if somebody can crack the least secure website, well, then they've got access to your password that they can use lots of different places. So don't reuse your passwords. Use a password manager. Use long passwords. We can see here with bcrypt trying to do a brute force attack. The longer it is, it's going to take dramatically more time to crack those passwords. So to protect yourself from attack, choose long, unique passwords. It's kind of like a game. When these websites get breached, and those password hashes get put up on the internet or on the dark web somewhere, people love throwing this data into Hashcat to see what they can find. It's like a competition. Who's the best password cracker? So these tools, John and Hashcat, very commonly used. I've spoon-fed you the syntax here. The Hashcat help will tell you all the different hashes it can do, and will also give you some different attack modes. There's a lot that you can tweak in order to make Hashcat run efficiently and effectively. We just kind of scratched the surface here, taking a look at the concepts of password attacks.